Think about this. You take your car to the gas station, fill it up with gas, which is actually not a gas but a liquid, and you start driving. How far can you go? Well, you go until you run out of gas. Now, take your car to the gas station, fill it up with gas, and now put your car on a rocket ship and take it up to the moon. Now how far can you drive? Well, actually nowhere, because there's no oxygen on the moon. The reaction in your engine is gasoline plus oxygen forming carbon dioxide and water. And if one of them is not present, your car doesn't go. Now, take your car to the gas station, fill it up with gas, and then take it to a mechanic and have a mechanic attach an oxygen tank. And now put it on a rocket and take it up to the moon. How far can you go now? Well, it depends on how much gas and oxygen you have. The point is, when either one runs out, the reaction stops, and so does your car. When there is more than one reactant in a reaction, which is often the case, the amount of product is dictated by the limiting reactant. This is the reactant that runs out first. The key to solving problems with limiting reactants is to determine which reactant is limiting and which reactants are in excess. Sometimes a problem will state which is which. Sometimes you have to figure it out. The calculation of the amount of product formed is then based only on the limiting reactant. As our first example, we use the combustion of methane, the reaction of CH4 with 2 moles of O2, to form carbon dioxide and water. We will again keep track of how much reactant we start with and how much product is formed. If we had a problem that asked how much product can form from the reaction of 2 moles of CH4 with excess O2, the problem tells us that O2 is in excess. Notice the coefficients tell us the reaction requires twice as much O2 as CH4. That means there must be greater than 4 moles of O2 present. It could be 5. It could be 5,000. How much more is irrelevant. CH4 must be the limiting reactant, and we base our calculation of product on the 2 moles of CH4. Consulting the balanced equation, we see that 1 mole of CO2 forms for every 1 mole of CH4 we start with, resulting in 2 moles of CO2 in this problem. Likewise, 2 moles of H2O form for every 1 mole of CH4 we start with, resulting in 4 moles of H2O in this problem. Our next question doesn't tell us which reactant is limiting. How much product can form from the reaction of 4 moles of CH4 with 10 moles of O2? We will have to figure it out. There are a number of methods for determining which reactant is limiting. The one we will use here is to take one reactant and ask how much of the other is needed based on the balanced equation. If we don't have that much, then the second reactant is limiting. If we have more than enough of the second reactant, then the first one is limiting. The balanced equation shows we need twice as much O2, or 8 moles of O2. Since we have 10 moles of O2, we have more than enough O2. O2 is in excess. Therefore, CH4 is the limiting reactant. Basing our calculation on CH4, we find that 4 moles of CO2 and 8 moles of H2O can form in this reaction. If the numbers are more complicated, we can appeal to conversion factors constructed from the coefficients in the balanced equation to determine the limiting reactant. For example, how much product can be formed from the reaction of 13.78 moles of CH4 with 27.28 moles of O2? To find out how much O2 is needed, we can construct a conversion factor from the 1:2 ratio in the balanced equation. Starting with the moles of CH4 and applying the conversion factor with moles of CH4 on the bottom, we find we need 27.56 moles of O2. Alas, there is not enough O2 present, so O2 is the limiting reactant. We will base our calculations on O2. If we need to, we can apply conversion factors constructed from the balanced equation to find the amounts of product. Notice that we form 1 mole of CO2 for every 2 moles of O2. So there will be half as much, or 13.64 moles of CO2 formed. We form 2 moles of H2O from 2 moles of O2, so there will be the same amount, or 27.28 moles of H2O formed. We have solved the problem by first determining the limiting reactant and then calculating the amounts of product formed from the limiting reactant. Notice that since CH4 was in excess, the 13.78 moles of CH4 did not figure into the determination of the amounts of CO2 or H2O. In summary, the first step to solving a problem where the starting amounts of more than one reactant are given is to determine which reactant is the limiting reactant. We use the method where we take one reactant and ask how much of the other is needed based on the balanced equation. Then we base the calculation of product on the limiting reactant. If the numbers are simple, we can use logic to figure the product. If they're more complicated, we can use conversion factors constructed from the balanced equation to calculate the amounts of product formed.